In the last video, we learned about analyzing graphs using increasing, decreasing, constant, maximum, and minimum. In this video, we're just going to do some more examples utilizing those features there. So let's jump right into my first example. This example here is given the graph, and this graph can only be defined as a piecewise function. There is no possible function here that will give me this graph without it being a piecewise function. But nonetheless, we still want to figure out where it's increasing, decreasing, constant, maximum, and minimum. Okay, so let's just start by tracing it from the left to the right. So the leftmost x value on this graph is identified by -10. Now, it does not have an arrow on the end of it, so I'm going to assume this is where my graph is starting at this point. If I trace my graph, notice my graph is going down, and it stops going down at this value right here. So that means my graph is decreasing starting at -10, my x value, and ending at this x value right here, which looks to be like -5. So the first interval where it is decreasing in interval notation is from -10 to -5. If you prefer set builder notation, the set of x's such that my x value is between -10 and -5. If I move on past this, starting here and tracing my graph, notice it is increasing. And it continues to increase all the way up to this point right here. And that point is x equals -1. So my first interval where it's increasing starts at -5 and ends at -1. And again, in set builder notation, the set of x's such that my x value is between -5 and 1. Let me remind you, you do not include any endpoints here. So in interval notation, all of our answers should be in parentheses. In set builder notation, we should only have less than or greater than, no, or equal to, because endpoints cannot be doing increasing, decreasing, or constant multiple different directions at the same time. Moving on, starting at -1, if I trace my graph again, it is going down. Therefore, it is decreasing, and it decreases all the way to this x value right here, which is 2. So my next interval is decreasing from -1 to +2, or in set builder notation, between -1 and 2. Moving on, the next part of the graph starts at -2, and it goes up. So it increases all the way to this x value right here, which is 4. So it's increasing between +2 and +4. Or set builder notation, where my x value is between 2 and 4. Moving on, my graph is staying the same. So it's horizontal between my original x value of 4 and my next x value here of 5, 6, 7. So it is constant between the values 4 and 7. And my last part of the graph is going down, starting at 7 and ending here. Since there's no arrow at the end, I'm going to assume it ends right there. So it goes down from 7 to 10, or set builder notation between 7 and 10. So hopefully you have a much better feeling about how increasing, decreasing, and constant work. Okay, now relative max and relative min, meaning any high points or any low points on the graph. So let me get rid of all this color shading here, and let me come back and let me try and highlight high and low points. So let me start with low points. So I have a low point right here, and I have a low point right here. And some might even identify this as a low point right there. And that one really depends upon what the textbook is specifically looking for. Okay, so if I identify all of these low points, and remember, maximums and minimums, high and low points, focus on the y values. So my first low point right here gives me a y value right here. So that is negative 1, 2, 3, 4, 5. So my first minimum is at negative 5. And if I want to know the location which this asks, I give the corresponding x value. So when x is equal to negative 1, 2, 3, 4, 5, negative 5. Okay. Another minimum is this right here. And so that low point, that y value is negative 8. And my location, meaning the x value that corresponds with it, is when x is equal to 2. If the textbook considers this over here to be a low point, that low point is my x value of negative 4, and the low point happens at the location when x is equal to 10. Okay, let's move to high points. We definitely see there is a high point here on the graph. So that high point gives me the y value of 3, and the location of that is when x is equal to negative 1. Now that is one relative maximum on this graph, but there's actually a couple other ones. Another maximum on the graph is a high point right here. So that one's unique because it doesn't happen specifically at one point, but it also happens all the way through this graph. So the y value in question is at negative 1. So the value of the relative maximum is at negative 1. And the location then is when I have multiple x values. When my x is between my 4 value and my 7 value. So there's multiple places where that high value or that maximum is happening. There's one other possibility of a maximum on the graph, and that is this high point right here. And so that high point happens at the y value of 7. And the location of that is when my x value is equal to negative 10. Okay, so we have worked through one example of finding increasing, decreasing constant, relative max, and relative min of a piecewise function. Let's do it again, but let's do it when we actually have a more of a polynomial type of function, like this example here. So these ones are going to be a little bit easier because our graphs are a little bit smoother. So it's going to be definitely defined what's happening on this graph. Now, even though it doesn't show it, we know that this graph is going to continue forever to the left, so we can interpret this as an arrow on the end here. And this graph is going to continue forever on the right, so we can interpret this as an arrow there. Okay, so starting with the left part of the graph, notice my graph is going down, so therefore it's decreasing, and it stops decreasing at this point right here, which looks like it corresponds to this x value right there. So my graph is decreasing, stopping at my negative 4 value. Well, where does it start? It starts all the way here on the left, meaning it starts all the way over here on the left. So my actual starting place on this is going to be negative infinity. Now that's a little bit misleading to students because they think, oh, well, my graph is going up forever, so that means my answer should be positive infinity. But remember, these increasing, decreasing, and constant are from left to right. So if we start at our leftmost place is identified as negative infinity. And of course, these are all in parentheses because we're not including endpoints in our interval notation. I'm going to skip the set builder notation from here, but if you would rather do that over the interval notations, that is perfectly fine. That's your personal preference. Moving to the next portion of the graph, starting at my low point here and going up, meaning I am increasing. So I'm increasing all the way from negative 4 up until 0. Tracing again, I'm going down. So I am decreasing all the way to this x value right here. So I'm decreasing between 0 and 3. And then going back up, I am increasing. So I'm increasing starting at my 3 value and it increases forever. So this means my final answer over here needs to be specified on the right. So if I look at the right part of the graph, that is represented by positive infinity. So I have two intervals where it's decreasing, I have two intervals where it's increasing, and I actually don't have any constant intervals here. So I'm going to put an NA for not applicable, or we can put none, or we can put something along those lines. Now, any time where it switches between decreasing and increasing, that gives us where we have a maximum or a minimum. So if it ever goes from decreasing to increasing, that means I have a low point on the graph, and that's where I have a minimum. So for example, where it switches from yellow to blue, I have a minimum here, and I have a minimum there. So what are those values? The value of that is my y value. So my first minimum is negative 1, 2, 3, 4, 5, 6. So the value of that is negative 6, and the location is my x value, so my x value is my negative 4. The other place where I had a minimum is here. My value is negative 3, and my location is the x value, so when x is equal to 3. Now, anytime I switch from increasing to decreasing, that means I have a high point on the graph. That means I have a maximum on my graph. So that happens when it switches from blue to yellow. So that happens right here. So my value of the graph is the y value of 0. My location of the graph is the x value, which also happens to be 0. And therefore, I think we have finished this example of identifying all places where it's increasing, decreasing, constant, which there wasn't any, and any maximums and any minimums. So that's where I'm going to stop this video. In the next video, we're going to do one more example of this, where we're going to find all 5 of these features here, but we're going to use our graphing calculator to do it rather than trying to do it by hand.